downstairs x is 0, right? So that's a critical. And then upstairs, what do I get? E squared? Yeah. So 2 minus ln of x equals 0 gives me ln of x equals 2, or e to the ln of x equals e squared. So x is e squared. And of course, let's look at that curve, right? I have ln of x divided by square root of x. It's really hard to see it, but what kind of tangent line? So obviously 0, x is 0 is not in my domain, right? So, but it is the left endpoint of my number line when I do that, right? And then it's hard to see it, but it's going up and then coming back down again at e squared. So let's see, x equals e squared. Right there is the high point of the hill. Very hard to see, right? Which is why you're kind of trusting the calculus, right? But if I do put that value in, what do I get? I get f of e squared is the ln of e squared over square root of e squared. So that's 2 over e, right? So we should be able to see that point at e squared comma 2, comma 2 over e. There it is. Hard to see, but again, you're using each part of it to kind of figure everything out. Use the graph to figure out the calculus, use calculus to figure out the graph. You okay there? Yes, exactly. Anything else? Sure. Gotcha. X to the 1/3 times x plus 4th. Nice. It's nice to see the graph first because it should give you kind of hints. So let's put that graph in. Y equals x to the 1/3 all times x plus 4. Ouch, it looks like a broken finger or whatever, but we clearly see a low point, right? So I'm thinking 1 critical for my x because it looks like it's decreasing all the way on the left, increasing on the right, of that low point. So f prime of x, I need a product rule. And nice and easy. So f prime of x is x to the 1/3 plus 1/3 x to the minus 2/3 times an x plus 4. And you see it's just kind of nasty. Again, I could factor this, but I'm going to do LCDs. I think LCDs are easier for most students to follow than factoring out a negative exponent. So I've got an x to the 1/3 plus x plus 4 over 3x to the 2/3. So I can clearly see I need this, right? I need this to get a factored fraction over fraction. Sorry, factored numerator over denominator. So I'm going to multiply this guy by 3x to the 2/3 over itself. So now I know my derivative is over 3x to the 2/3, and in the numerator, I have a 3x plus x plus 4, right? It's cheating. I mean, it's not cheating, but it's thankfully works out that way. So clearly it's a 4x plus 4 over 3x to the 2/3. So it looks like I get a critical of -1 and 0. Zero is in the domain, but what's happening at 0 on the graph? What do you see what's happening at 0? Yeah, it's vertical. I got a vertical tangent at 0. So at 0, there's actually a hole in this graph, right? Not in this graph. I'm sorry. It's undefined. The derivative is undefined at 0, right? It's not going to change much about my test. Yep. And of course, we want to look at that -1, and it's pretty obvious, right? When I say x equals -1, it's going to hit that low point. That's where I'm going to get my min. So homework 4 due Monday. We're going to start quizzing on Wednesday. What are we quizzing on first? And I've scheduled, it looks like I'm going to be able to get 8 more quizzes in at least. Quiz on Wednesday, quiz on Thursday, quiz on Monday, quiz on Tuesday. Oh, maybe not. No quiz on Tuesday. Tuesday's quiz-free day. So I should be able to get 6 more quizzes in. What am I talking about for quizzes? I'm definitely going to do, how many do I have so far? 15? Thought I had more than 15. Did I have 19? Yeah, 19. Did I not return some quizzes yet? That's bad. So I'm thinking quiz 20 is abs, min, and max. Quiz 21 is first derivative test. So those 2 on Wednesday. Quiz 22, second derivative test. Quiz 23, optimization. Quiz 24 is going to be the area problem, which I didn't learn yet. It's chapter 5. And quiz 25 will be antiderivatives. U sub integrals. We didn't learn that yet either. So we didn't learn these last few pieces yet. And then I'll be happy to drop 5 quizzes. I think 5 quizzes. If we have 25 quizzes, I'll drop 20% of them. On Wednesday, yeah. Yeah, this is Wednesday. This is going to be, these 2 are going to be Thursday, and then these 2 will be Monday. Sorry, Thursday is an R. So the first 2 Wednesday, next 2 on Thursday, and then the last 2 on Monday. It's almost over. Can't believe it. It's great. Next week's our last week. We have final on Thursday of next week. So our schedule here, you can see it. I've got this week, I'm doing 4-6 today, and then I'm starting chapter 5. Then the following week, finishing chapter 5, and then a review on Wednesday, test on Thursday. Anything else from homework or the test that you want me to do? Nice. Two cos theta plus cos squared theta. I just use x. And we're on from 0 to 2 pi. So obviously, this is kind of hinting at the absolute min-max problem, that I need to test the heights of my endpoints because they're going to be possible min or max, right? Whether it's local or absolute, doesn't matter. Make sure you include these endpoints. So I'm assuming the derivative is the hard part, but derivative of cos is negative sine. Derivative of cos squared is 2 times cos times a negative sine. And in this case, I can factor out a negative 2 sine x. So what's left over? I got a 1 plus a cos of x. Is that okay? Yep. So I know two things here, right? A times b is 0 means a is 0 or b is 0. So I know negative 2 sine x equals 0, or 1 plus cos x equals 0. This one is giving me sine x equals 0, which I know happens at 0, pi, and 2 pi. And this one is giving me cos of x is negative 1, which I know happens at pi. But I've already got that, so my criticals are here. So I'm assuming the issue is here, taking the derivative of this. Yeah, so you're trying to factor. You're if it's you're looking for quadratic formula, you're looking for factoring, you're looking to get a single fraction, right? So all of those little things. I think now that you've seen this again today, you've seen that LCD twice already. That's the tricky one, right? Where you have something plus something, but one of them really is behaving like a fraction, so you want to think of LCDs in that case. How are we doing? Good. So we can. So what we're going to do today, I'm going to do optimization. It's a little bit heady, so it's going to be a little dense for us. So we'll probably do it in two with a break in between. We'll work on optimization with a break, and then we'll leave a little early today, probably 2:20 or so, so that if anyone you want to talk to me about your grade or that type of thing. I don't think you should drop the class, okay? But again, if you're going to repeat, if you got something in the 30s and 40s and you repeat that on exam 2, it's unless everything else is perfect, it's hard to get a C. So if you had a low first grade and you repeat that, it's not going to be good unless everything else is perfect. Homework is perfect, quizzes are very good, and the project is done. Okay? So, but we could talk privately at the end if you want to. All right, here we go. 4.6, optimization. If you have a business, what do you want to maximize? Profit, right? If you have, so we're thinking about, right? Let's say you're making clothes, right? And you're cutting out patterns of clothes from sheets of fabric, right? So I'm cutting out patterns for pants. What do I want to minimize? Exactly. You want to minimize the wasted fabric, right? So that's what we're talking about. We're talking about minimizing or maximizing something based on the situation, okay? And so the problem types that I like are geometry and min distance. So any of those in the section are fair game and good for you to do. So just looking at that section, I'm looking for some kind of geometry or some kind of mention of a min distance. And I'll see if I can get the screen a little bit larger. Here we go. So for example, number 5, find the dimensions of a rectangle with a perimeter of 100 meters whose area is as large as possible. Anything with geometry in it, okay? Number 11, I have cardboard. I'm going to make a box out of it, right? The base is square and the sides are rectangles and the top is open. So I'm trying to use the amount of material I have to get the largest possible volume of the box. So any kind of geometry, I like it. 27 is tough. That's geometry. But if we look at number 15, I've got an ellipse, and I want to find 2 points on the ellipse that are furthest away from the point 1, 0, right? So any kind of min distance problem. The min distance problems are difficult, but I'm going to completely set you up with everything you need today, including a step-by-step. So you can try any geometry problem, any min distance problem, okay? Let's just pick one to start here. Let's do number 5. So find the dimensions of a rectangle with a perimeter of 100 meters whose area is maximized. Now, I'm doing this one without telling you how to do it, and then I'm going to write a step-by-step down, okay? So just bear with me as we do this problem. And I will say it when I'm doing this problem, but I'll write it down when I'm doing this step-by-step, okay? I want to draw a picture here if I can. So I already know, so this is, 4.6, number 5, right? We want to find the dimensions of a rectangle with a perimeter of 100 meters and a max volume. Max area. So obviously the picture is the rectangle, right? And we're in almost all of these, we're going to have two variables. We could have a third variable that we have to try and get rid of, but on almost all of them, we're going to have two variables. So I'm just going to pick this side as x and this side as y. I'll just always use x and y unless they tell me something else. And I want to maximize the area. So I want to be able to, from my picture or from the argument in the question, to find an expression that has to be maximized or minimized, and an equation that will help me do it, okay? So my max area is going to be x times y, right? And my perimeter is 2x plus 2y equals 100 meters, is what they told me. So from the question, or from the picture, I should get an expression that is going to be used to get my min or max, and an equation that's going to help me. An expression and an equation. So once I have these two things, I can create a single function in a single variable, right? If you notice here, I could solve this for y, right? So I get 2y equals 100 minus 2x, or y equals 50 minus x, and plug that into the expression. So now I have maximize f of x equals x times 50 minus x. So I'm going to come up with an expression in two variables, an equation in two variables, solve for one of the variables in the equation, substitute it into the expression, and that becomes a function of one variable that I'm trying to maximize or minimize. Clearly, this thing is, right, it's a parabola opening down, so clearly you see I'm going to get the top of a hill here. And my derivative is 50 minus 2x. So that critical value is what? Yep, 25. So 25 meters is my height of my rectangle. Once I find my derivative, I find the critical value, and then I start trying to answer the question. Okay, well, I got part of the dimensions of my rectangle, 25 meters. I got to get the other one, right? So I know that 2 times 25 plus 2y is 100, right? So it looks like y is 25 as well. Is that right? So it turns out my rectangle is a square, right? So I'm trying to conclude. I want to answer the question completely, right? If x is 25 meters and y is 25 meters, then the area is maximized of what? 25 squared. Of 625 meters squared. So far, okay, not too bad, right? Long, lots of writing, lots of things to think about. We're gonna have a very long step-by-step that you're gonna make your own by practicing. The one last thing I want you to do is use that last bit of the second derivative test to verify you have a maximum, right? Verify x equals 25 is a max using f double prime. So what was f prime of x? F prime of x was 50 minus 2x. F double prime of x is what? Negative 2? So f double prime of 25 is negative 2. If f double prime of 25 is negative, f prime of 25 is 0, and f of 25 is real, then x equals 25 is a local max. Right, from our second derivative test. If the second derivative is negative, negative people frown. When you're frowning, you got the top of a hill, right, in the frown, and that's how we know we have a maximum. What do you think? What do you think? You okay? Yes? Mike? Yep. All right, here's the step-by-step. Don't let me go too fast if you're still writing now. You're okay? All right, step by step. Use the question to create a diagram that yields an expression to optimize and an equation to help. You know you're looking for something to maximize or minimize, and then something else is given to you. Right? Solve for one variable in the equation to create a function of one variable that will be optimized. So I've got my picture from that, or from the information in the problem. I've created an expression and I've got an equation. Step 2, solve the equation for a variable and sub in, right? Step 3, find f prime and the critical values. Of course, you can use a graph at that point, right? Answer the question in detail. Check the min-max with f double prime. That's not that long. Not that long. I put a couple steps together, but that's okay. Okay, so far? All right, let's do another geometry problem, then we'll take a break, and then we'll do the problem I put on every test, right, which is a min distance problem, okay? Let's see. Number 11 is good. Yes. I am in no rush, right? So I can always go back. Um, just like you, I would like to have the class over with already, but oops, sorry. Okay, good. So this is number 11. It says I have a 1,200 centimeters squared of cardboard or material to make a box with a square base and an open top. So already I can draw a picture here. I got a square base, and the top is open, right? So that's open, right? Everything else is solid. The base is solid, the sides are solid, right? But the top is open, right? So I know the base is a square, that's x by x, and the height I don't know, so I'll call y, right? So I have one square base and 4 other sides, which are x by y. Yeah, that making sense? I have 4 side panels, right? And 1 base panel. I want to maximize the volume. So I need an expression to maximize, and I need an equation to help, right? So what is my volume? It's x squared y, right? So that's 2 variables. I want to change it into a single variable. Yes. What is my surface area? Nice. Nice. X squared plus 4xy equals 1,200. We don't care about the units. We understand units, right? I'll let your science teachers deal with you in units, but I know if it's a 2-dimensional, it's going to be centimeter squared. If it's 3-dimensional, centimeter cubed. 1-dimensional, just centimeters, right? So I'm not worried about that. I'm worried about the the numeric values. All right, first step is done. What's the second step? Take my equation and solve for y. That's going to substitute into my expression to give me a function of x. And of course, the more I can simplify it, the better. But it's just me being kind of picky. Step 3, find, everybody okay here? Don't let me go too fast. No one's okay? So step 3 is find the derivative, find the criticals, right? Looks like I got a product rule here. You don't have to do your algebra like I am. In this particular case, yes, I could get an LCD, but it's still going to just be me solving for 0, right? So f prime of x equals 0 implies 300 equals 3x squared over 4, or 1200 equals 3x squared, or x squared is 400. So x must be 20, right? And of course, we know it's 20 centimeters. We have to find y. We already know that x squared plus 4xy is 1200. And with x equals 20, we can put in that 20 squared plus 4 times 20 times y equals 1200. Say again? Yes. Yes. So yeah, once we found that critical, we're not sure it's the max yet, but we're gonna do it graphically and do it with our second derivative. But yeah, so once I find, remember I already knew that my surface area was here, and that's where I'm going to get the y from, right? My surface area was x squared plus 4xy equals 1200. Yeah. Yep. Where to? Yeah. Yes. Yep. Say it again. Say it again for me, Tia. Exactly. It's the critical of the first derivative, and it's giving us a dimension of the box, right? Or etc. We don't know if well, we know it's a maximum, and in this case we only had one critical value, right? If we had two critical values and they both gave us a maximum, we'd want the larger one, of course, right? We're trying to get the largest possible or smallest possible. So far we have a conclusion. Uh, right? A box with a square base and open top with a surface area of 1200 centimeters squared has a max volume of 20 squared times 10, which is what, 4,000 centimeters cubed, with dimensions x equals 20 centimeters, y equals 10 centimeters. What was our derivative again? 300 minus 3. So f prime of x was 300 minus 3x squared over 4. And f double prime of x is minus 6x over 4, which is minus 3x over 2. And f double prime of 20 is negative. So x equals 20 is a max. Oh my god, so boring, isn't it? Let me just stop this video for a second.